It's just going to be devoted to a review. Before we do that, let's mention what the final exam is going to look like. 1 week from today, it's on December 13th for this section. It's going to consist of two parts. The first part is 24 multiple choice questions plus 9 ungraded survey questions. This is separate from the student evaluations, the course evaluations, which you should also be filling out. You should have received a message through Canvas on filling those out. You can fill those out now or later. It doesn't matter, it's anonymous. I won't see them until January anyway. But the 24 multiple choice questions are worth a total of 66 points. It should take you no more than 45 minutes to complete that. Then the second part is a programming exercise, which is cumulative in that it relies on variables, file IO, loops, etc. But there is an emphasis on structures, searching and sorting techniques. So emphasis on more recent materials, but of course recent materials is dependent on previous material. It's going to be worth that part is worth 84 points, so 150 points total. 9 points for the usual style, documentation, and design, and then 75 points for correctness. You'll submit that through the web hand-in. You can use the web grader. You can resubmit as many times as you want up until the due date, which we'll talk about here in a second. There are several parts to that exercise. So partial credit is possible, but only if you submit compiling working code. Right? So non-working code may be given a 0. That means if there are 5 reports that you have to run, right, and the first one works, the second one works, the third one crashes with a seg fault, and the fourth one works, get rid of that third one, right? Take the hit, don't get a 0 on it, turn in what actually works, okay? You'll have 24 hours to do it, right? Both of those parts together should take no more than 2 hours, right? It was designed that way because the usual final exam time is only 2 hours. But I'm giving you that 24-hour period in which to do it. So you don't have to do it whenever it was actually scheduled. You can, you should. But otherwise, both those parts will open up in Canvas at 12:01 a.m. Both of those parts will close at 11:59 p.m. that same day. All times are central, whatever we're on, daylight savings time or standard time. Right? There are no makeups, so plan ahead. Make sure that you are not starting at 11 o'clock at night. Give yourself enough time to complete everything. There's no collaboration of any kind. Make sure that you are not accessing websites that you shouldn't be. Make sure that you are not collaborating with another student inside or outside the class that you shouldn't be. We will, of course, be running MOS as usual and monitoring hand-in logs and checking things out. Okay. Any questions on the final exam? No? Okay. Then, like I said, the rest of the time is going to be review. As I teased last time, I've got this fan database of Pokemon and this official database of Pokemon. There are only 800 official Pokemon according to the database that I grabbed. And then I you'll note here that they're not in any particular order either, right? They're randomized. And over here in the fan database, there are 805 Pokemon. So there are 5 fake Pokemon that are fan created. One of the things that I want to do is find those Pokemon. Which ones are the fake ones? Okay. To even begin doing this, we need to, of course, load this data up into a C program. To do that, we need a way to model the data. So this is encapsulation, right? If you want to, a Pokemon is a name, a type, fire, and then a secondary type, dragon here. Fighting, normal, whatever. These numbers are associated with their HP, their hit points, how much energy they have that you can attack before they die or whatever. This is their attack points and this is their defense points. So those items are what I want to capture in a structure. Yeah, go ahead. I got it from kaggle.com, which is a website that has a lot of data sets. And then I changed it around to make it a little bit less trivial because all of them have unique numbers, and I didn't want that because then you could find the fakes really quick. All right, so I want to model this first as a data structure, right? As a structure that contains all those pieces of data in one logical unit. Right? To do that, I use type-def struct. Right? And I'm going to call this structure Pokemon, right? Because that's what it is. It's one single Pokemon, okay? And it's going to have those things. This is again, this is a name. This is the first type. This is the second type. Not all of them have a second type. Attacks, this is HP, hit points, attack, and defense. So each one of those things are going to have to be modeled. Should I do it with this? Const char star name, const char star type 1, const char star type 2. Right? We saw some of this, at least initially, when you were designing your airports on Hack 11. Is this going to work? What is the const out front doing? It's ensuring that you cannot make changes. Right? So if you can't make changes to this name, how are you ever going to set it to begin with? We can't make them const. Okay? So they are all strings, char stars, right? But they are mutable. They're changeable strings. Then we've got integers, right? They're all integers. They could, I guess you could do doubles, but I don't think that that's what the game does. The first one is hit points, right? Their total energy or whatever. The second one is going to be attack points. I don't know what the scale is in this game. Again, I've never played this game, so forgive me if I make any mistakes. Defense, attack, and defense. Right? Oops, and then I've already got it down here. Okay. So there's a Pokemon. What else do I put at the end? Because this is a declaration of a type, right? I need a semicolon. Okay. Note here that I had semicolons throughout. I didn't have commas. Commas would be for an enumerated type because an enumerated type is a list. This is not a list, right? It is defining what elements are part of a Pokemon. Okay. Remember that we are online and a lot more people are watching online today, so if you have any questions, go ahead and use the YouTube chat or comments. I've also got, I pre-prepared a little bit because I didn't want the focus to be file IO, but I do have a function here to load up the CSV data and parse out each one of these lines, which is a CSV file, comma-separated value file. So instead of writing it from scratch, let's review it, okay? It takes a file name and a number of records. Why does it need to know the number of records here? First of all, this is being passed by reference or is this being passed by value? Int star is a pointer. Therefore, it's being passed by reference. This is how we're going to communicate back to the calling function how many records we loaded up from that file. Okay? The calling function needs to know that because what are we returning? We're returning an array of Pokemon, right? And it needs to know how many are in there. If I did it by value, right, then I can't make changes to the original variable, so there's no way to return this value here. Okay? The first thing we do is basic error checking. If you gave me a bad file name or a bad pointer for the number of records, I simply return null because that's the only thing I can return. I'm returning a pointer. It would be wrong to return 1 or 2 or 3 because those it's a memory address, and I'm referring to the memory address 1, 2, or 3. Right? Next, I establish a buffer so that I can read this line by line by line. 1,000 is probably big enough for anything in either of these files. All right? Back to this one over here. Then I open up the file for reading. Right? If the file opening failed for any reason, that the file didn't exist, or I didn't have permission to read it, or whatever, I simply return with a null pointer. Right? Otherwise, remember the first line is the number of records in that file, 805 and 800 respectively. So I'm going to read that first line using fgetS, file, get string. It gets the entire line, one entire line, and places it into buffer. I then call A to I on buffer, converting that over to a number, n, 800 or 805. I then set that pointer value that I received here to n, because that's how many records I'm going to read. Okay. Then I've got Pokemon data, which is an array of Pokemon. I call malloc, however many bytes a Pokemon takes, times n, because that's how many I'm going to create, 800 or 805. I then go into a traditional for loop because I know how many records there are. I don't need to go into a while loop and read all the way to the end of the file, right? What if the file contained 805 valid records and then 50 blank lines? Do I want to read those 50 blank lines? Nope. Right? I'm going to trust that first line, and I'm only going to read 805 records after that first line in this case. Right? And that's why I've got a traditional for loop here. I read the entire line, and then I start breaking it up. I start tokenizing it using strtoke. The first time I call strtoke, I pass in the thing that I want to tokenize, the buffer, right? And the delimiter that I want to use. Since it's the CSV file, comma-separated value file, I'm going to separate it based on commas. Right? I'm going to tokenize it based on commas. Each time I call strtoke after that, I pass in null to continue tokenizing the same string. The first token is the name, then type 1, then type 2. Those are all both strings. But after that are numbers, right? 78, 52, 60, right? For example. So I use A to I, A to I, A to I to convert all of those. At this point, I've got those 6 pieces of data that make up a Pokemon. I then call init Pokemon on those 6 pieces of data and the ith Pokemon here. What does that ampersand in front of it mean? I'm changing it into a... the I does dereference it, but then it's a regular old structure, so I need to change it into a pointer to a structure, thus the ampersand. Right? Now I have not written this function, so let's do that next. But I also make sure to close out the file and then return the data. Okay? So you've written now init functions for books, and we did that in class. You've done it for airports. You did it for teams in a lab, maybe something else, I don't know. But what's the difference between an init function and a create function, like a create Pokemon? Right? Create Pokemon is going to create the memory, like calling malloc, to create a brand new instance of it. Init assumes that it already exists. Right? It's the ith Pokemon. And in this case, it does already exist because we malloced it up here on line 25. So I'm going to go ahead and just implement this init Pokemon function here. Let's come over here. Make sure that you have proper documentation. Right? If you're going to write a function, then you need to document it. And this one simply initializes the given Pokemon, right, passed by reference, right, with the given data, ... Well, that's it, yeah. Right? So it's going to take a Pokemon, const Pokemon star P. Right? Now, should I have const in front here? Const means I'm going to be making changes, that I can't make changes to it. Am I going to be making changes to it? Damn right. Right? So, no const. Now let's actually write the function over here in the source file. Right? To do basic error checking. To do basic error handling. Right? For example, if the Pokemon is not is null, or if const char star name is null. This is something I forgot to do. Const char star int hit points, int attack, and int defense. Right? If any of these pointers are null, name, type 1, type 2, or P are null, then I can't do anything. Return, right? That begs the question, what should my return value be here if I'm going to be doing basic error handling? An integer, right? I could make this void, and then there's no way to communicate the back to the calling function that something bad happened, right? So I'll go ahead and make this an int. And let's fix the source file, the header file over here. There we go. Now they match. I'll leave that as an exercise for you, though. Right? Again, if any of these things are null, that's bad. If hit points or attack or defense are out of scope, right? If you know the rules to Pokemon, maybe you know what they are. I don't. Right? I don't know if hit points can be 0 or not. I don't know if they can be negative or not. I don't know if there's an upper bound to them or not, right? That's why I'm leaving this as a to-do basic error handling, right? Okay? Otherwise, what we need to do is we need to copy that name into P's name, right? So copy name into P's name, right? Is this how I do it? P dot or arrow name is equal to name. Here's my first attempt. My first question is it a dot or is it an arrow? When do we use a dot? When you've got a regular old structure, right? Dot. But when you've got a Pokemon or a structure pointer, what do you use? Arrow. It's really easy to remember, right? If you've got a pointer, what is the arrow doing? It is pointing, right? So if you've got a pointer, use the pointer thing, the arrow thing. What do we have here? A pointer. Therefore, we use the arrow. P's name is equal to name. Now, is that correct? What kind of a copy is that? There are two kinds of copies. What are they? There's a string copy, but there are generally there's two types of copies. A shallow and a deep copy, where we've got shallow, two references to the same thing, so that when one changes, whatever this is, it's reflected in the other. We probably don't want that. That's what this is, right? That's a shallow copy right there, right? So let's make this a deep copy. How? We need to do a string copy, right? To do that, we need to set up enough space. Char star, a call to malloc. Right? How many bytes do you want? Well, however size of char, however many bytes a character takes, times 5. HELLO? No. What do you want to copy? You want to copy name. So how many characters are in name? How can we determine that? STRLEN of name. Is that enough? HELLO. Do I only need 5 or do I need 6? Why? Null terminating character. Exactly. There we go. And now I can use strcpy. Copy into the Pokemon's name. Right? Cut, paste for type 1. Cut, paste for type 2. Or even better, what should I be doing? Putting this into a function. A function that we've now seen at least 3 or 4 times. Right? Char star deep, whatever you want to call it, string copy. Const char star s. Right? Now, if I put those 2 lines into this function, it's taken care of for me. Of course, I'm not going to use something like name. Instead, I'm going to say char star copy is equal to string length of s plus 1 for the null terminating character, and then into copy s. Now I can reuse this function over and over and over again, right? Oh, what did I just do? This belongs over there. Sorry. This belongs over here if I'm going to use it. And over here in the H file, all I want is a prototype. There we go. And now I can use it over and over and over again, right? Deep string copy of name. Right? Get rid of all that. Do the same thing for type 1 and type 2. Type 1, type 2. There we go. Do I need to worry about deep versus string versus shallow copies for, say, hit points? Nope, they're just regular old variables. Hit points. Hit points, attack, defense. Attack, attack, defense. Ooh, defense. There we go. And defense. All right. Now, if I am doing basic error handling up above, I should return 0 for no error down below, if everything went fine. Okay? Great. Now I'm at least loading up the data and initializing my array of Pokemon types. Over here, I've got a main that opens up the fan database and another one that opens up the official database. N and M both capture those values 805 and 800 respectively, whatever the order is. Okay? So let's write some reports here. But before we do that, let's make sure that loading the files actually worked. Right? we're going to find the Pokemon with the highest hit points, the one with the lowest hit points. We're going to find all fan Pokemon that are not official. Right? Before we do this, let's do some ad hoc testing here and make sure that that file loading passed. So for int I equals 0, I is less than, say, n, I plus plus. We're simply going to print out all of the fan Pokemons. Right? Print Pokemon, fans of I. Right? Now, did you see a print Pokemon function somewhere? Nope. I sure wish one existed, though, so that I could use it right here and print it out conveniently, because I'm probably going to be printing stuff out down here, and I'm certainly going to be printing stuff out down here. Well, it's Christmas time, so go ahead and give that gift to yourself. Right? I want a function that prints a Pokemon given a Pokemon by reference. Then write it. Right? Come down here. I'm not going to get fancy. I'm just going to go ahead and print the Pokemon's name, %s, their type, the first type, comma, the second type, and then those three numbers, %d, %d, %d. Right? And then end the line. You can make this as fancy as you want. You can columnize it. You can do whatever, right? P's name. Why am I using arrows here again? Because it's a pointer, right? Type 2. And then P's hit points. P's, what was that? Attack. And P's defense. There we go. All right, so let's test this and make sure it works. Is that correct right there? Fans of I. Well, let's ask the compiler. Incompatible type of argument 1 to print Pokemon. Fans of I is a Pokemon. It expects a pointer to a Pokemon. Right? Fan is a Pokemon pointer. It's an array of Pokemon. So when you get the ith one, that changes it into a regular old structure. To change it back into a pointer, what do we do in front of it? Ampersand. And it will now compile. And it'll also run. Right? The last one is Diggersby. The first one is Warmadam Sandy, whatever it is. Right? And that was in the fan. Warmadam Sandy is the first one, and then Diggersby is the last one. And then we've got 85, what was it? Come on. 85, 56, 77. So I'm also convinced those are being read incorrectly. Read into memory correctly, not incorrectly. Okay, great. Oops. My ad hoc testing was successful. I'm going to comment that out so I'm not printing out 800 things. When I go to hand this in, though, that better be gone, because that's just cruft. Right? I'm going to leave it in for now because maybe I want to come back to that and print some stuff out. Okay? Now, our first report. Find the Pokemon with the highest HP. Find the one with the lowest HP. Sounds mighty familiar. Find the book with the highest rating. Find the book with the lowest rating. Right? Our first iteration of that solution was to write our own algorithms that simply went through with a flag value that said the maximum index that I found so far is this one. Then I'll compare that to the other one and another one and another one. If I ever find something larger, I update that index, et cetera, et cetera. Is there a better way? What was the second iteration of our solution? The comparator, and then we put that comparator into Q sort and sort. If we were to sort them by HP, right, in ascending order, where would the lowest one be? In ascending order, right? So 5, 10, 15, 20, right? So where would the one with the lowest be? Up here at the top. Where would the one with the highest be? Down at the bottom. Much more elegant solution, right? Let's do it. So here's my outline. Again, this to-do and all these comments are gone in my final submission because that's cruft, right? Sort the array by hit points, right? In ascending order, ... You already told me that the tool to do that, the built-in tool, is QSort. Should I even contemplate writing selection sort or copying over that selection sort from my lab 13? Nope. This particular exercise only has 800 records. 800 squared, which was what selection sort would end up doing, is not that big of a deal. 800 squared is what? 640,000? Something like that? Right? That's not that big of a deal. It'll take a matter of seconds to run. I can guarantee you that your final exam will have data, big data, on the order of 1 million or 10 million records. If you're doing something like selection sort, where there's n squared operations, it ain't happening. Remember our estimate? It was 4.5 months to get that done. Don't go that direction. Right? This won't take 4.5 months because it's small enough, right? Now I did, when I started out this exercise, I did look up how many Pokemon cards there were because I wanted a very large data set, a very large real data set, and there were only 13,000 or something like that. So that database was still not big enough, and I wanted to simplify the review exercise anyway, right? And that's when it became a review exercise instead of the actual final, right? All right, so QSort. What am I sorting? I'm sorting that fan database, say. Right? What's the next argument in QSort? Anytime you pass in an array, what else do you have to pass in C? The size of the array. In this case, I've captured that value in n. Right? With QSort, what's the next argument that you have to provide it? Size of each one of the elements in the array, right? That's the size T size. In other words, it's going to be the number of bytes that a Pokemon takes, which is size of Pokemon. Right? Why does it need to know that? Because if it's sorting an integer array, it needs to know to take these 4 bytes and these 4 bytes and swap them if they're out of order. If it's sorting a double array, it needs to know to take these 8 bytes and these 8 bytes and swap those 8 bytes. If it's sorting Pokemon, which are, say, 36 bytes, then it needs to know to take these 36 bytes and these 36 bytes and swap those instead. Right? And then what's the last thing that we pass in? It's that comparator that you were talking about, right? A function pointer, right? Well, it would be mighty nice if I had a comparator, a function comparator that compared Pokemon by hit points in ascending order, right? You can go ahead and shorten that if you want to. I'll just go ahead and keep it like this because it's most descriptive. Right? Do we have that thing? Nope. Christmas. You get old enough, nobody buys you Christmas presents anymore, right? Instead, you have to buy your own Christmas presents, right? And then you get what you really want. So it's actually better that way. I just want the money. So I don't buy myself anything. All right, so this is going to take 2 Pokemon and return an integer. Something that's something negative if they're in order, something positive if they're out of order, and 0 if they're the same thing, if they have the same hit points. Okay? So does it take 2 Pokemon? A, Pokemon B. Yeah, is that a comparator? What's a comparator? It's that thing, right? That is way too specific. That's not generic programming, right? Const, void, star A. Right? Why the const? Because we're not going to make changes to it. I promise. Right? Void, because it is no specific type. It's not a Pokemon. It's not an integer. It's not a double. We have one function type, one comparator signature that works with QSort. It's going to be a pointer because that's how things are done in C. You always pass things by reference, not by value. Okay? All right. There's my comparator. Come back, do your documentation. Okay? Implement this. What's the first thing that I do in a comparator? Do I have enough information about what A is in order to compare their hit points? Nope. So what do I need to do? The pointer thing. Pokemon X, right? The star X is equal to const Pokemon star A, right? Putting this out front is doing a typecast. It's forcing that generic raw pointer to a memory address to then become magically a Pokemon. Right? Now, if we were to use this comparator to sort an array of integers, right, then we're going to definitely get a segmentation fault there. But that's on us. Right? There's really no way to check. Are you actually typecasting this safely? C is not that strong enough of a language to be able to do that. You need a full strongly typed or strongly typed, statically typed. It doesn't matter what you use, which term you use. You need a better language, a language with stronger typing features, right? Like say Java. Right? Definitely not say Python, which has even weaker typing standards. Right? Typing as in not typing A, B, C, D on the keyboard. Typing as in what type of variable is this? It's a const Pokemon star. Right? Okay. Now I do have enough information to compare X's hit points to Y's hit points. Right? So compare X's hit points to Y's hit points. Well, how do I do that? X dot or X arrow? Remember, how do you remember that? We have a pointer, don't we? So which one of those things points? The dot or the arrow? The arrow points. Right? Hit points versus Y's hit points. Okay? I want to compare those two. Now let's think about this for a moment. Right? You might immediately jump to the solution. But what if we've got 5 hit points versus 10 hit points? What should the result be? Remember, this is in ascending order. So are those in order or out of order? They're in order, so we return something. Return something negative. All right, and you're right, I'm not going to get fancy. I'm going to go ahead and return -1. Right. For a moment, though, let's think about something else. What if it was 10 versus 5? Return something positive. Right. What if it was 10 versus 10? Return 0. Now, you might be tempted, after you see this thing in the wild, to use this all over the place. Don't do it. Right? The temptation is as follows. What if I take X's hit points and Y's hit points, and I simply take the difference between them? Okay? So, 5 minus 10 gives me what? -5. Oh, okay. What about 10 minus 5? What does that give me? +5. 10 minus 10, what does that give me? 0. Does that follow our pattern? It does for integers, right? And so that's the integer difference trick. Right? And it probably works for Pokemon, because I think that the highest hit point for a Pokemon is 255. Right? You won't have that much problems with small integers, but what happens when you have, say, 2.1 billion versus -2.1 billion? What happens to your math now? 2.1 billion minus -2.1 billion becomes what? 4.2 billion. Is that expressible by a 32-bit 2's complement integer? Nope. What's the maximum value? 2.147 billion. So what ends up happening is this becomes a negative number due to overflow. Right? Don't do tricks like this. Right? The difference trick is not worth it. The number of use cases that it would actually work is so small that you might think, okay, well, you'll get in a bad habit of trying to apply it everywhere. Don't do it. Right? Tricks are for kids. Right? If X's hit points are less than Y's hit points, then we return, like you said, -1. Don't get fancy. Just return something negative something negative, -1. Else if x's hit points are greater than y's hit points, return +1, although we don't write it like that. Right? We write it like that. Else, return 0. Excellent. There's our comparator. Now I copy and paste and move my ad hoc debugging code here to make sure that that sorting actually worked. Now if I print all these out, it should be in ascending order with respect to that first number that it gets printed out. At the very end here, we have 255, then 250, 190, 170, 165. At the very top here, we're going to have the lowest hit point Pokemon, which is Shedinja with 1. Is that a joke Pokemon then? Okay. Whatever it is. Oh, nope. Let's go ahead and preserve that just in case. But now I can fill out my report. Where's that highest Pokemon? It's the last one. Right? So printf, highest HP Pokemon is, and then we can print Pokemon fans of, and then it'll be the last one, which is at n-1, index n-1. Why n-1? 5 things, 0, 1, 2, 3, 4. Because of 0 indexing, you always start at 0, and you end at n-1. Right? Where's the one with the lowest hit points? At index 0 at the very top. Right? Let's make sure that this works. Yay. That Blissey at 255 and Shedinja at 1. Okay. And there were no ties, but we could have reported everything with a hit point of 1. We could have reported everything with a hit point of 255. Right? Okay. Questions so far? How would I go about doing this for, say, attack? What if I wanted, say, to do find the Pokemon with the highest attack, right? Or lowest attack. Another comparator, sort it just like I did here, report the high, report the low. Find the mean attack, defense, or hit points. Right? That's going to be roll your own function, where you sum everything up and then divide by the number of elements there are. Right? Find the median. The median is the thing in the middle once it's sorted, right? So sort and get the element at index and divided by 2. You're doing all of these things right now, by the way, in your 13 TAC, right? I'm going to leave that as a to-do. What I want to do instead is find all the Pokemon that are in the fan database that are not in the official database. Those 5 random fan-made Pokemon, the ones that aren't real, although they are not, none of them are real, right? So, sorry. Anyway, how do we go about finding those fan-made Pokemon? Ideas. Note, a Pokemon in our data is identified by its name. Its name is unique. You'll note here that when I started out with this data, it did have like a unique identifier. Each one had 1, 2, 3, 4, an ID in a Pokédex or something like that. I got rid of that data because I didn't want to use it. Right? I wanted to use. I just wanted to use this data. There's a whole bunch of other data too, right? I don't know. I don't remember what I took out, but it wasn't relevant to the exercise. There you go. Specials, whether or not they were legendary, whatever that means, and a couple of other things, but I took all those out. Right? So a Pokemon in our data is identified by its name. How can we find those fan ones that are not in the official database? Ideas? Okay. Sort by, say, both by name. Then, say, for each Pokemon in the fan database, search the other official database, right? If found, it is official. Ignore it. Right? If not found, then that's one of the things that we're looking for. Right? It's in the fan database, but it's not in the official database. Right? It is not official. Report it. Right? Right? In fact, I think that some of them that I took are from like a fan-made game that Nintendo, had some copyright issues with and took them down. Right? So we're Nintendo now. We're finding those unofficial Pokemon so that we can get our lawyers to draft a letter and tell them to take it down. Right? All right, so first step. What do I do? Q sort. What's that going to look like? Exactly the same as this, except that if I'm sorting by name, it's going to be by name. I'm not going to put ascending in there because that's generally the default. That's what's known as a natural sorting, right? It's always in ascending order, lexicographically, numerically, whatever. Right? And it really doesn't matter if we sort it in ascending order or a descending order. We're going to search for it by the same criteria. Right? I'm going to go ahead and sort the fan database, and I'm also going to sort the official database. Official database. Remember, however, that the official database only had M elements in it. 800 versus 805. Do I have this comparator? Nope. So let's write it. Oops. What's it going to look like? It's going to have the exact same signature as my other comparator. What's it going to look like over here? What's the first step? Get them into the pointer types that you expect. I'm not going to compare their hit points, though, if I'm going to do this by name. What do I use here? Yeah, there's something already built in there for me, right? Return strcmp of X's name versus Y's name. Right? Reuse what you have. strcmp is not technically a comparator, but you can use it because it follows the same pattern here. It's going to return something negative, positive, or 0, depending on the relative ordering of those two things. Done. Come back over here. I'm not going to bother to ad hoc test this. I'm pretty sure that it's going to work. So for each Pokemon in the fan database, that looks very much like the loop that we had before. Right? Search for it. So search the official database. If found, then it's official. Ignore it. If not found, then report it. Okay? How are we going to search the official database? There are two options, right? Two algorithms that we looked at. Linear search, and what was the other one? Binary search. So, is it applicable here? Can I binary search the official database? I can if it's sorted. Right? And again, not that big of a deal. 800, 805, linear search is nothing. You get into the actual final where there are millions or tens of millions of records, and it matters. Right? Okay? So let's come back over here and let's do a binary search. To do a binary search, I need a key, Pokemon key. That's going to be the ith Pokemon in the fan database. Right? There we go. And I'm going to call bsearch. Bsearch returns a Pokemon pointer, which I'll simply call result. Bsearch. What does bsearch look like if I'm searching for in the official database here? Same 4 arguments that you use to sort it, but then you also pass in the key as the first argument, and that's the only difference. Right? And then, of course, it returns something. I'm going to leave a question mark here. You're going to tell me how to pass in that key in a moment here. If it's found, then it's official. Ignore it. If it's not found, it's not official. Report it. How do I know if it's not found? If bsearch fails to find it, what does it return? What's the only thing it can return if you're returning a pointer? Null. So if it's not found, report it. Printf found a fake or fan Pokemon. Right. And then print Pokemon key. There we go. So now help me out. How do I pass in that key? Is it just like that? Man B search. Let's remind ourselves of what it looks like. It takes a const void star key. It takes a pointer to whatever you're doing, well, whatever you're trying to search for. Is key a pointer? Nope. So how can we make it into a pointer? Ampersand. If this works, we should find 5 Pokemon that are not official, and you can tell me whether or not they're official. If you, how many people could guess that they're not official if given them? 1, 2, okay. There we go. I think the first one is actually, it's named for a fan. It's a Fangarm. I don't know. Fangarm, Hexnia, Misleoth, Palisagion, and Volpan. There we go. Those are all fake, and I also made up their hit points and stuff, right? I just had to make up the data. Right? 1, 2, 3, 4, 5. I'm convinced that it works. All right. Any questions? No? All right. Oh, sorry. Go ahead. So I'm going to search the official database for the ith Pokemon in the fan database, right? Well, the ith Pokemon is fan Savai, right? And so I'm just putting that into another variable called key, right? Now, the key itself, the key is going to have a name and then the other stuff, but I don't care about the other stuff because this comparator only looks at the names. I could have made a dummy key and then copied in the name, but I didn't. Why? It's already there, right? And the key as I've got it here is just a regular old structure. It expects a pointer to a structure, therefore I need a ampersand here. Right? Now to close all this out, of course, I would go back and remove all this stuff. I'll leave it in there, but that's cruft. Right? Here's a good question. What if I were to, it's obviously running, it's just fine, but what if I did a val grind on this, right? So let's go ahead and recompile everything with the G flag and go val grind a.out. Right? I'm not going to get a clean bill of health, am I? 2 errors from 2 contexts, all those errors are going to be memory leaks, right? Does it really matter? Not for this exercise, right? The memory leaks are actually in main, right? When these functions create an array of Pokemon here, right? Then ownership is transferred to the main function here. So the main now owns these things, but the main is going to die anyway, right? It ends its execution right here, right? If you wanted to make sure that there were no memory leaks in the report itself, you would need to clean up here, right? ... right? But no point since the program is about to end, right? ... right? But if you wanted to, what would it look like? Yep, you'd have to free fan and free official, free fan, free official. Right? There we go. That's part of it. Let me go ahead and recompile and see if we now get a clean bill of health. We'll get a better bill of health, but we still won't get a clean bill of health. Why? Each one of those Pokemon have a name, type, and another type. So they have 3 strings associated with them. All that memory is still being leaked. So what should we do to clean that up? Right. Clean up these strings, ... For int I equals 0, I is less than n, I plus plus, right? Free fans of I dot or arrow, right? Dot name, or name, right? So I'm going to clean up that string. Dot or arrow here. Note that it's different than everything that we've done up to this point. It's going to be a dot. Why? Because that's not a pointer, right? Once you reference the ith element, then that's one Pokemon and that's not a pointer. That's a regular old structure. So you use the dot operator there. Name, type 1 and type 2. There we go. You have to do the exact same thing for all the official ones. Official, official, official. And there are M of those, not N. Right? And now we should get a clean bill of health everywhere. Yay. No memory leaks at all. If you're going to do something like this, though, you would put it into a destructor function, right? Free Pokemon instead, right? And then you could, call that one function that frees these three things, call that one function that frees these three things, and then free up the actual arrays themselves, right? This is for bonus brownie points. Pokemon points that aren't real, right? So extra good, but not necessary. Right? All that stuff. Yeah?
So when main closes out, it frees up memory units?
Yep. That'd be a fundamental operating system problem if it didn't successfully reclaim memory. Then the operating system would have some sort of a memory leak.
Is that just like a waste of time, or a waste of clock cycles then?
It's a good question. For a small program like this, I'd say yes. But you don't want to get in the habit of not cleaning up stuff, right? Because then most programs are going to be long running, right? They're going to be running, monitoring stuff and whatever, like a web browser or something, or like me running OBS right now, right? It's been running for now an hour. If it had a memory leak, everything would be grinding to a halt by now, instead of just heating up my CPU. What is it? It says only 7.8%, but the fans are going. Right? All right. Any last questions on that? If it manifests itself as like a segmentation fault, that's different. That's not a memory leak. That's an illegal, that you're trying to access memory that doesn't exist or doesn't belong to you. But otherwise, we don't run val grind on the grader. We tried, but it was way too slow. I'd have to see what it is. It could be like a malloc double free, or it could be that you've corrupted memory and now freeing it is not a valid operation or something, right? Okay, I'd have to take a look. Right? The other exercise that we have here is, if we want to do it, otherwise if we just want to go over and start checking off resubmissions or whatever, is day one on advent of code. It looks like it's pretty easy or straightforward. I don't know if we could get it done in 10 minutes though. Right? Basically, you're given a series of numbers, and you just want to you want to find the maximum sum. So, for example, 1,000, 2,000, 3,000, that sums up to 6,000. 4,000 is just by itself. 5,000 and 6,000, that's 11,000. Right? 7, 8, 9,000, that's going to be 15, 24,000, and then just 10,000 by itself. You want to report that maximum value, 24,000. Right? Each one of them is broken up by an empty line, right? And so you would want to process this line by line from a file. I've not gotten my input, but let's take a look and see how big it is. Right? Hey. Let's go over here and create a, do I have advent of code somewhere? Nope. All right. Well, fine. We'll make one. New advent 2022 day 1 a.c. And then we'll probably also want a bunch of input files. So advent 2022 day 1 dot input, or dot input dot txt. There we go. All right, so we've got 2,000 things here. Right? Any Excel gurus? You could throw this into Excel pretty quick and do a grouping and get an answer like instantaneously, and then just take a max. Actually, just highlight them all and then take a max. Right? Anybody know how to do that in Excel really quick? No? Okay. Then I won't bother. Right. So how would you do this in C? Read it line by line, right? Start a sum that up until you see the next blank line, right? Report that as your total, right? And maybe even store that as your total. Then start the sum over at 0. Plus, 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 right? In fact, there might be a pattern here. 8. How many are here? No, there's 9 here. There's even more there. 2 there, 1 there. So it's not consistent, so you won't be able to break it up consistently. But then you'd restart the counter here, count them, sum them all up, maybe store that result or something like that into another array, store that result in another array, do whatever, right? We're not going to have time to do that, though. Right? But we'll do it next time, unless, yeah, we'll redo it next time. I don't know. I'll probably end up doing this exercise in the other sections. We can redo it here. Or we can do it like day 2 or go on to day 3, day 4, whatever. I don't know how complex they'll be, but this one's pretty simple. All right, then I'll see you over. Yeah, go ahead.
When you open up CSV and look at it, and you load them as a folder of structures, you do that just by...
If this were on my desktop, if fan.csv were on my desktop and I double-clicked on it, it would open up in Excel.
Yeah.
Yeah.
I guess I was messing around with the hack, and I was like, well, I wanted some data, so I made a data in CSV, and I went and found a bunch of reports, and I was okay with it.
That's what we're doing on the grader.
Yeah, I guess that's it. But then I thought, well, why can't I just have like a chunk for like 7 reports? Why can't I just copy paste into my code and skip all the...
You could do that. What we could have done over here is the same way that we did our dummy keys, right? Pokemon A is equal to, well, what is a Pokemon? It is a name. It is a type 1. It is a type 2. It's a number, and a number. You're done. Right? Type B, copy, paste, copy, paste. If you want to, I don't know, here's a trick. Let me do them all. Okay. Find and replace. So A to Z. And this is going to be literal. This is going to be a regular expression. A to Z with, I need to capture those values. So replace it with this. This is not going to work fully, but there we go. Yeah, I didn't want that. Nope. I don't want to replace that. But A to Z star, A to Z star, and then replace that. Do I do 1? And then 2? Nope. Okay. No, those are literals. Undo, undo. Dang it. How do I do groupings? Is it like this? And like this? Anyway, you could do powerful regular expressions here to change all that stuff so that it's in the proper all right, no, darn it. I forget how to do groupings and regular expressions off the top of my head. But you could go ahead and just do a really quick regular expression here and not have to do file IO at all. Yeah, like the advent of code input here, right? So let's go ahead and put that in there and find and replace all end-line characters with commas and then the end-line character, actually commas and spaces so that they'll all be on one line, right? There we go, replace all. There we go. And Now I can just put that into an array, int array, done, no file IO. Right, and now there are some here that are blank, so what you could do is then you don't even need a regular expression for this, so shut off regular expressions. Anything that's blank here, convert it just to a non-blank, replace all. All those blanks are gone, but you've lost too much information and you can't do the exercise now, right? So maybe undo that, and I know that none of them are 0, so let's go ahead and replace it with 0, and that'll be my flag value, or actually -1, that'll be my flag value to indicate that this chunk separate this chunk, right? And replace all. There we go. And now I'm ready to do that exercise with no file IO at all. Right? Right. There we go. Just replace this with, in fact, I could put this into a header file, rename this advent blah 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 .h, include it, and I don't have to worry about it anymore. Right? Cool? I should go through and count up the number of things that I have here, although I could do that over here by just counting the number of commas. Find commas and not replace, but tell me how many commas there are. Find. There are, oh, there's not total? Oh well. Where is it? 22, oh, there we go. There it is. 2248, and so you've got commas in between, so therefore you've got 2249, and that's the size of the array. 2249. Or something like that. I might be off by 1. But there's the idea. Right? And now you see how people can get on the leaderboards in a matter of seconds. Right? They could throw this into Excel, and if you're an Excel guru, you know a group, highlight, there's my answer, done. I did it in like 2 seconds to copy and paste. Right? I know that it can be done in Excel, I just don't remember how to do it off the top of my head. Right? And then other people can just do, like I would have put this into Python as one big giant string and let Python take care of the parsing for me, right? With a list comprehension or something. All right. All right, I'll see you over there, and we'll do these exercises on Thursday then.